So let's have a look at this. What do we have? E to the minus 2x, 2x minus 1 to the power of 5. Right, what I can see here is that I have got a product. Okay, a product of two separate functions. So now I'm going to say u equals e to the minus 2x and v equals 2x minus 1 all to the power of 5. U dash differential of the power minus 2 and keep the rest of it the same. V dash, bring the power down, take 1 away from the power, times by the differential of what's inside the bracket. And if I just simplify that first, I get that. Now it's a case of cross multiplying. So dy by dx, v times by u dash, so 2x minus 1 to the power of 5 times by minus 2 e to the minus 2x plus u times by v dash e to the minus 2x times by 10 2x minus 1 to the power of 4. And I'm just going to write this out in a neat format. So I didn't say you had to have it in a factorized version or anything like that. So you could have essentially just written it in a nicer version. So I'm going to take the numbers to the front and maybe I'll write e's at the front as well. So 2e minus 2 e to the minus 2x, 2x minus 1 to the power of 5 plus 10e to the minus 2x, 2x minus 1 to the power of 4. I could quite easily leave it like that because the question didn't say put it in a particular format, but seeing that we did practice that a little bit, I'm now going to just go ahead and think about this. So minus 2, positive 10. I'm going to factorize out 2 here. I think about e to the minus 2x, e to the minus 2x. They're common, so I'm going to take out e to the minus 2x. I've got 2x minus 1 to the 5, 2x minus 1 to the 4, 2x minus 1 to the power of 4. And then I will write the whole thing out again. And divide by the highest common factor found outside, so divide each term by that just to be clear. Right, so what I can do, well, e to the minus 2x, e to the minus 2x is gone, minus 2, I've got 1 here. Cancel all of this out with this. So the thing inside the square bracket I've got is 2x minus 1. 10 and 2, 5 at the top. This cancels out with this. And then this cancels out with this. So I've got plus 5. I've got 2e to the minus 2x, 2x minus 1 to the 4. And so, sorry, this should be minus by that because there's a minus left over. And a good idea, like I might have said before, is to put a 1 there after the minus, so that when you're expanding it out, you've got the right thing. So 2e to the minus 2x, 2x minus 1 to the 4, minus 2x plus 1 plus 5. So I've got minus 2x plus plus 1 plus 6 is plus 6. So I can take out 2 from here, make that a 4, e to the minus 2x, 2x minus 1 to the 4. Divide all of this by 2, and so I get minus x plus 3. Okay, check your answers against that. So part B, we have got sine 2x, if I call it y equals sine 2x cos 3x. I've got product of two functions, so I'm going to say u equals sine 2x and v equals cos 3x. U dash, when you differentiate sine f of x, f dash of x, which is 2 sine becomes cos, and this becomes 2x. V dash is minus 3 sine 3x. And now I can cross multiply, so divide by dx, cos 3x times by 2 cos 2x plus sine 2x times by minus 3 sine 3x. And so I would write this as 2 cos 2x cos 3x. And then positive times by negative is going to become negative. 3 at the front, sine 2x, sine 3x. There's nothing common here, so we can't factorize anything out. And this is it. This is our final answer. Okay, there's actually nothing in common. At this stage, there isn't. Maybe if you use your double angle formulae, then you might be able to take something out, but we'll leave that for now. That might be a really tricky trig proof question. Right, okay. So you're getting the hang of that. One last question. I'm going to get you to do D. I don't want you to factorize it. Right, let's have a look at D here then. So I'm going to just go straight into it. U equals sine 5x and V equals ln cos x. Okay, so u dash is going to be, when I differentiate sine f of x, I'm going to get f dash of x cos f of x. And when I differentiate ln f of x, I get f dash of x over f of x. So I should have got minus sine x over cos x. Or alternatively, you could also have said minus tan x as well. It's up to you. It doesn't really matter at this stage, because you've not been asked to show that it is equal to something. Okay, so now using the product rule, now I'm going to have ln cos x times by 5 cos 5x. Now, I just want you to know that we don't multiply cos x by that. You would work out the square bracket first, and then you would multiply it by 5 cos 5x. Okay, very important. You never multiply the cos bracket with something outside the ln. And then what do we have? Then we've got plus v, so sine 5x, times by minus sine x over cos x, or you could have had minus tan x. Now the only thing I'd say there, positive times negative is negative, and so I'd write this as ln cos x. I'll take the coefficient to the front, this number term here, so I would write the numbers at the front, and then I've got cos 5x here. And then positive times negative is negative. I've got sine 5x times by sine x over cos x. Or you could have put the division over the whole thing. It doesn't really matter there as well. Okay, is everyone happy with that? Okay, so product rule was obviously when we had a product. Now the quotient rule is for when we have y equals u over v. Okay, it's very specific. Your numerator is u and your denominator is v. So if we have some function at the top divided by some function at the bottom, that will then allow us, the quotient rule will allow us to differentiate that. So in that case, dy by dx is going to become vu dash minus uv dash all over v squared. Okay, and the proof for this comes from writing it like this and then using the product rule. Okay, because now I've got product of u times by v to the power of minus 1. And if I use the product rule on that, we get the quotient rule. You can probably do most quotient rule things using the product rule. The quotient rule is especially beneficial for certain trig proofs. Okay, so that's why you learn about the quotient rule. Now, let's see how this translates into some questions. Let's just have a go at this. So I'll show you how this works out. So y equals x over 2x plus 5. So now, again, like we did previously, we know this is u and this is v. So we're going to write u equals x. So u dash is going to equal 1. V equals 2x plus 5. So v dash is 2. And now we just plug everything into the quotient rule. So dy by dx, it has to be in that order. You can't change that order, especially in the numerator. V times by u dash. So 2x plus 5 times by 1 minus u times by v dash all over v squared, which is 2x plus 5 squared. And then what we can do is simplify the numerator, 2x plus 5 minus 2x all over 2x plus 5 squared. And so we are left with 5 over 2x plus 5 squared. And there is your dy by dx. Is everyone happy with that? And firstly get to dy by dx and then we'll take it from there. So curve with that equation. So my initial instinct is to do u equals sine x and v equals e to the 2x. So u dash is going to become cos x. V dash is going to become 2e to the 2x. And so dy by dx is going to equal vu dash, so e to the 2x cos x minus uv dash sine x times by 2e to the 2x all over v squared, so e to the 2x all squared. And if I just sort of write this in a nicer format where e to the x's are at the front, and maybe factorize e to the 2x out, e to the 2x times by cos x minus 2 sine x, and let me write that a bit neatly. I've got 2 sine x all over e to the 4x. Now what's going to happen is this is going to cross out with this to leave us with e to the 2x there. Okay, is everyone happy with that? And I would leave it like that. I wouldn't take the e to the 2x up to the top. And I'm going to explain to you why in a second. Okay, so just check your answers. You should have had e to the 2x here in the denominator. Right, okay, so now, where is the gradient equal to 0? The gradient's going to equal 0 where dy by dx, or stationary point, is where dy by dx equals 0. So therefore, cos x minus 2 sine x over e to the 2x should be equal to 0. Is everyone happy with that? That is where we are going to find our stationary point. But the problem is that in a fractional function, only the numerator can equal 0, not the denominator. Because if the denominator was equal to 0, then we would get an undefined function. So you always have to remember, when a fraction is equal to 0, only the numerator is equal to 0. Please make a note of that wherever you are working. And this is especially important for the quotient rule. When you make a fraction equal to 0, only the numerator is equal to 0. And I'm just going to put an asterisk there saying only make numerator equal to 0. All right. And then from there, this should become more straightforward, depending on how much of trig you remember. So cos x equals 2 sine x. What am I going to do with this? You guys are going to tell me now. I need to solve this between 0 and pi. What is my next step here? Divide both sides by cos x. That's good because we want to get tan x. Yeah, so I get 1 equals 2 tan x. So tan x is equal to a half. And we only want x between 0 and pi, so we are only looking at the top half, only one angle in A. And so we can do inverse tan of a half. What do we need to make sure here? What do we need to make sure over here when we type this into our calculator? It has to be in radian mode because our range is in radians. So setup, shift menu, angle unit, radian, and then I can do shift tan of 0.5 and we get x equals, I think it's a 3SF 464. And we'll put a C for radians. So start off by saying u equals sine squared x. Now, is that a good format for me to be able to try to differentiate that in? You guys tell me, is sine squared x a good format? If we ever have trig ratios to any power, you need to make a note of this. Trig ratios to any power, we want to do, put it in square brackets and write it like that, so that we can use the chain rule to differentiate it. So u dash is going to equal, bring the power down, take 1 away from the power, and multiply it by the differential of what's inside the square bracket, which is cos x. So we end up getting 2 sine x cos x. Or if you wanted to be fancy, you could have said sine 2x as well, because that is one of the trig double angle formulae. So u is that, v is simple, ln x, differentiate that is going to become 1 over x. Yeah, that's fine, yeah. So now if we think about dy by dx, vu dash, so ln x times by 2 sine x cos x minus uv dash sine squared x 1 over x all over v squared ln x all squared. Now, what's important to understand is ln is a function, so we need bracket here. Sine is a function, and these things are not to be multiplied with other terms outside of those brackets. Okay, and this again, ln is a function, so these brackets won't change basically. And so can I write this in a simpler format? Maybe could write 2 ln x sine x cos x minus sine squared x 1 over x all over ln x all squared. And again, maybe I'll just put the functions where the x's won't change. I'll put them in a different kind of bracket or bracket around them to indicate to myself that that cannot change. We can check that. Right, okay. Yeah, it's the same thing there. Right, any questions there? So can you please tell me how many of you got that differentiation of sine squared x wrong? How many of you differentiated sine squared x incorrectly? Okay, so now you know, put it in inside square brackets for trig terms. So we're just going to make a note here. Trig powers, we're going to say put in square brackets. Okay. That is the key thing.